All right, the last of the three types of transformations that we're going to talk about with functions are stretches and shrinks. So we saw translations change the location of the graph. It moves it to the left, to the right, up or down. Reflections change the orientation of the graph. It's going to flip it one way or the other. Stretches and shrinks are going to change the size or the shape of the graph. In geometry, this was the idea of a dilation, okay? So with functions, we call it stretches and shrinks. Now, whenever you see a stretch or a shrink, it is going to occur from multiplication in your function somewhere. Translations were addition and subtraction. Negatives cause a reflection when you multiply. And then ignoring the negative, the value of A, whatever you might be multiplying by, tells us about a stretch or a shrink, okay? Now, if I have my parent function, let's think about this graphically a little bit here. Let's think about the absolute value function. So here is the parent function of absolute value. A vertical stretch is going to pull all my y values up, and it's going to make it narrower, like that, taller and narrower. A vertical shrink is going to press my y values down, and so that's going to make it wider. When we are looking at stretches and shrinks, the A value is a multiplier on the outside of the function. So an example would be y equals 4 times the absolute value of x. For a quadratic, maybe it might be 1/3 x squared, okay? Now, the A value is the number that you're multiplying by. So in this first case, A is equal to 4. And in this second case, A is equal to 1/3. And now at the bottom of the page, it's kind of covered up by the words, but this is an important rule right here. It's considered a stretch when A is greater than 1, and it's considered a shrink when A is between 0 and 1. Less than 0 would make it negative, and as we saw before, reflections are what happens when there's a negative. So the negative has its own job. We're just looking at the numeric value. So since 4 is bigger than 1, that would make this transformation a stretch. And since 1/3 is between 0 and 1, that would make this one a shrink. And that's all vertically, okay? Let's consider then what's going to happen if I look at the graph of an absolute value and I stretch or shrink it horizontally, okay? If I stretch horizontally, that means I'm going to grab the sides of the graph and pull it away to the right and to the left. So that's going to make it wider. And if I take the sides and I push towards the middle, that's a horizontal shrink. I'm going to compress my graph this way so that it gets taller, and that is a shrink. Now, if you're thinking, wow, that graph looks a lot like the one on the top, it does. Horizontal stretches and shrinks do the opposite of vertical shrinks and stretches. So I could say a vertical stretch or a horizontal shrink, they are going to do the same thing. So when we're writing a function, we prefer to write vertical stretches and shrinks because they're easier. But they do the exact same thing, but since x and y are in opposite directions, it has the opposite effect. So a horizontal transformation, as I mentioned with translations and stuff, horizontal is always the weird one. It has always kind of an extra step. So this idea here is we're not just multiplying by A. That 1/A means the reciprocal of A. Remember, the reciprocal means flip it over. So if I had 2/5, the reciprocal would be 5/2. So to figure out the A value, we have to flip the number that we see. So let's work with those same equations from up above, okay? So if I make these horizontal, that would be the absolute value of 4x. So I would put the 4 on the inside. But now, because the value of a is the reciprocal of the number I see, that now makes a equal to 1/4, which tells me that this graph is actually going to be a horizontal shrink. Oops. Okay. Similarly, if I put the 1/3 in parentheses with the x to make it an inside multiplier, the number I see is 1/3, but that means a is equal to 3/1. And that makes this a horizontal stretch. Okay. Now, again, on the top one in the orange, a is equal to 4. That's a vertical stretch. On the top one in the green, a is equal to 1/4, and it's a horizontal shrink. But remember, looking at the picture, those are going to do the same thing to the graph. Okay, it's just going to be a different way of how we go about it. All right, so let's see if we can identify these. So in this section, there are different kinds of multiplying. We've got the numeric value and we've got some negatives. In the previous video, we talked about reflections. A negative always causes a reflection. So like in number 15, the negative, I'm going to decide what kind of reflection that does, and then I'm going to consider the 2. The negative is not going to be a part of that because it has its own job. Okay, so pause your video and see if you can identify 13 through 16. What is the parent function and what is the transformation or plural transformations that have been applied? I will come back with the answers in 3 seconds. Okay, so functions, quadratic, absolute value. Whoops, I didn't write it on this one, but number 15 is linear, and then quadratic on the last one. So number 13, that 2 is not in parentheses, so that tells me it's an outside multiplier, and that means that it is a vertical stretch by 2 because a is equal to 2 here, okay? Number 14, absolute value, that 1/2 multiplier is inside the absolute value, so that tells me that it's horizontal, and since I see 1/2, that means a is 2, so it's a horizontal stretch by 2. On number 15, linear is the one that can always go both ways. So you could either read this as an x-axis reflection with a vertical stretch by 2, or a y-axis reflection with a horizontal shrink by 1/2. It's either or, not both, but either answer would be correct. And then lastly, number 16 has an x-axis reflection because I see that negative on the outside of the function, but the 2/3 is multiplying on the inside of the squared, which makes it a horizontal stretch by 3/2. Okay. Last thing to talk about today is how do we perform this kind of a transformation on the graph itself, okay? Now, if we scroll back to this page for just a minute, this is the key here. If you have a vertical stretch or shrink, that's going to multiply the y values of your function. If you have a horizontal stretch or shrink, that's going to multiply the x values of your function. And so that's exactly how we're going to apply it here on our own. So we have the function graphed as f of x, describe the transformations that have been performed based on the function given, and sketch the graph of the new function following the transformations. Okay, this multiplier of 2 is on the inside, so this is going to be horizontal. A is equal to 1/2, so that means this is a shrink by 1/2. So what that means is that we multiply the x values by 1/2, keep the y's the same. Okay, so here's the idea. This x value on the far right is 6. So half of that is going to be 3. But the y value is 5, so it's going to stay 5. So instead of being at 6, 5, now I want half of that, which is going to be 3, 5. Again, the y value stays the same. And so we're going to keep going with that. This next ordered pair is at 3, -1. So now I want it to be 1.5, negative 1. The next one is at 1, 1, so I want it to be at 0.5, 1. And then the last one is at negative 2, so half of that x would be negative 1, negative 2. So you see that horizontally, the y values all stayed the same. They're on the same level, but it just looks like we put our hands on the two sides of the graph and pressed it towards the y-axis, kind of like a slinky or a spring. We're just squishing it down, okay? So for B, this one is definitely vertical because it's on the outside. 3/2 is 1.5. We want 1.5 of every value. So that's a vertical stretch by 3/2. So that means, again, same idea. This one is vertical, so we're going to keep our x's the same, but all of the y values we're going to multiply by 3/2 or 1.5. So if I look at this graph, I come to my x equals 6. I'm going to keep the x value the same. So I'm going to stay on that line of x equals 6, but I'm just going to change my y value. So I have 5. 1.5 of 5 will take me to 7.5. And you can use a calculator to figure that out. I know that 1 of 5 is 5. Half of 5 is 2.5. So add them together, you get 7.5. Okay. So then the next one, at 3, I'm going to stay at x equals 3, but my y value, which is negative 1, I'm going to multiply that by 1.5, so I get negative 1.5. Same thing here, 1.5 in the other direction. And then negative 2 times 1.5 is negative 3, so that's going to come down here. And so it didn't change a whole lot, but what we can see is it looks like we grabbed the top and the bottom and just pulled it towards the top and the bottom a little tiny bit, okay? So that's the idea of a stretch and a shrink. It always comes from a multiplier. And remember that trick with the horizontal, we have to remember to look at the reciprocal of the number that we see. Vertical is always normal. Horizontal always has an extra little step. And now we've seen all three transformations.